Hello, Honors Algebra 2. We are on day 11. We're going to solve exponential equations using logarithms. So, first directions is solve the following equations. If necessary, round answers to 3 decimals. Please go grab your calculators right now. I'm going to show as much as I can on the calculator to help you out, and then we'll do our rounding to 3 decimals. Quick clarification on the assignment sheet. If you look at day 11 assignment, so take a moment, day 11, it is page 267, number 2 to 14 even, but it wants us to ignore the directions on 14 to 24. The directions for 14 to 24 are solve the equation by first transforming so that the base is 10. Ignore that. Don't worry about getting it to a base of 10. We're going to show you ways in the video today on how to solve problems like 14 to 24. You do not need to get them to base 10. Let's jump in and get started. Know that this is just one potential way to solve these logs. If your teacher has a different way and you like that way, use it. If you like this way and you like it better, use it. Okay, it's up to you, whatever is easiest for you. First one, 10 to the x equals 457. Now, my initial goal would try to get them to have like bases. However, I don't think I can get 457 to a base of 10, so I'm going to instead choose to do the log function. I'm in exponential and I'm stuck, so I'm going to head to log, which means I'm going to take the log of both sides. When you take the log of both sides, the exponent will pop to the front. You're going to get log of 10 on the left. On the right side, you're going to get log of 457. Notice the only thing that happened is the exponent gets popped up to the front and is being multiplied. This now makes it much easier to get x by itself, because I can just undo multiplication with dividing log base 10. So I'm going to do that to both sides. That means I'm going to get x equals log of 475 over the log of 10. If you see this, you can just change log of 10 to 1. It's equivalent. Okay, log base 10 of 10 is just going to be 1. If you don't see it, that's okay for right now. You're going to type it in your calculator and it's going to simplify out anyways. Okay, so let's do it now in the calculator. Your log is on the far left side. Log, we're going to do a 457, close the parenthesis. Okay, it's very important that you close the parentheses so that your log is of just the argument 457. We're going to divide it by 1, or if you don't see it, log of 10, again, close the parenthesis. Pops out is 2.6599. We're rounding to 3 decimals, so we're going to have it be 2.660. So x equals 2.660. Next example. We now have 10 raised to the negative x equals 2.034. Notice that the exponent is where the variable is. It's in exponential form. To get out of exponential form, I'm going to take the log of both sides, which means the negative x is going to be multiplied in front of a log base 10. When you do log on one side, you need to apply it to the other side. Now that you logged both sides, I can undo this multiplication with division. Notice again that log base 10 of 10 is just 1. you're left with the left side of negative x equals log of 2.034 over 1. Same fact as before. And you have to get x, so make sure you do one last step of dividing by negative 1. I'm going to type this in my calculator now. I'm going to go log on the left side, 2.034, close the parenthesis, and then divide by negative 1. Don't forget to close the parenthesis, and you get x to be negative 0.30835. So rounding to the third decimal, x is going to be negative 0.308. This is one potential way. Heading to our next example, we have 10 raised to x equals negative 1.57. Let's do the same idea. X is in the exponent, so let's bring it to the front by taking the log of both sides. And then something might be jumping out at you. There was a fact we talked about a couple notes ago about your argument. But if you don't see it, let me walk through so that it pops out to you. You're going to undo the log of 10 being multiplied, but you know log base 10 is just 1. This is what I will be typing into my calculator, and we're going to see what kind of solution our calculator is going to give us. So I'm heading back. You have the log. It is of negative 1.57. Close the parenthesis. Mine just says none. You probably will get no solution, out of domain, error. All of this will happen because of the fact that the argument's negative. And you're like, oh, right. Your calculator helps you, but you should know from the beginning this won't be able to work. Okay, you cannot have a negative argument. I'm going to even write a note here. No negative argument. If you accidentally forget and you try to solve, you'll get an error. So that's why in the end we know this is not possible. And you can also think about it. If I have a positive number 10 raised to x, there is no way I'm going to get a negative. You could get a fraction. You could get really, really, really close to 0, but you'll never be negative. So both ways, however you want to look at it, however you see it, or your calculator will help you out as well. Let's try a couple more. We have our x in the exponent, so to move that down, you're going to put it in front and take the log of both sides. We're going to undo that multiplication by just dividing by log of 54.3. Log of 54.3. In your calculator, hopefully you can do that, and you will get 0.712. Verify that you can get that on your calculator. Make sure if you didn't get that you close your parentheses. Now we have ones that are a little bit more complicated, but treat it like an order of operation. You have to move stuff out of the way before you can do your log of both sides. So first thing you're going to do is divide out that 21.4, because that's in my way. I'm left with 10 raised to the 0.4x. 94.2 divided by 21.4 is 4.402. Our variable is in the exponent, so we're going to log both sides to be able to get that exponent in front. It's being multiplied. I'm going to jump to the fact already that this is just 1. Eliminate another step for me, because we know log base 10 of 10 is 1. So all I have is 0.4x equals log of 4.402. Just want to get x by itself, so let's divide by 0.4. You can do that in your calculator, and you should get x equals 1.609. If you did not get that, parentheses. Last one in exponential form. Again, the variable is in the exponent, so we're going to move it to the front by applying the log to both sides. So the exponent is coming to the front when we log our base of 5, so argument of 5, an argument of 125. I like to put the parentheses there because that whole term that was the exponent is now being multiplied. So if you put the parentheses, it's very clear to see that you're going to divide by log of 5 first. And then you have 5x minus 1 equals that. In your calculator, you'll see that that's just 3. You can use some of your log properties as well without a calculator to know that. And then you solve here. Add 1, divide by 5, you will get 4/5. But treat it as a group, 5x minus 1. Almost done, you're doing great. All of the problems we have just done have been in exponential form. The first thing we did is put it in log form, right? Take the log of both sides. Notice now we're in log form. You might think, if I was in exponential, I went to log. Now I'm in log. You'll probably go to exponential. This is one potential way. So let's first combine this into a nice log expression on the left. Because you are adding like logs, you're going to multiply your arguments. This is a rule that we learned in the past video. Now I'm stuck. I'm in log and I don't know what to do. You have to remember there's always a base 10 in a log. When there's never something written, it's always 10. If I put it into exponential form, you'll take 10, your base, raised to the 2, equals my argument, 2x. That's just changing log to exponential. Well, I can solve this now. I want x. All I need to do is divide by 2. X is 50. You could also have something that looks like the last example. Log of 20x minus log of 2 equals 0.6180. You're in log, so let's simplify. When you are subtracting like logs, you're going to divide your arguments. I'm going to show what that looks like. Really then, I have the log of x equals 0.6180 because the 2's will cancel. I'm in log form and I don't know what to do. I'm stuck. Best thing to do, remember there's a base 10. Let's put it into exponential form. So it's 10 raised to the 0.6180 is going to equal my argument of x, my unknown. Oh, guys, I am so sorry. Just rereading the problem. This is a 20x. Oh, you guys are like, this is amazing. She made a mistake, but I found it. Yes, I did. So it is 10x. One final step is divide by 10. Right? Get the x by itself. So x is going to equal 0.415. I apologize about that. If you were watching diligently, you probably caught it before I did, so awesome job with your video skills. If not, just make sure you copy the problem down correctly, like I fixed. Again, this is one potential way. Okay, if you do not like this way, your teacher might have a new way. If this works for you, then it works. You guys got this. Good luck.